All right, an arc is a connected piece of a circle. So if I have a circle and I have 2 points on the outside, the arc would be the distance between those 2 points here. That would be our arc. It's like a line segment because it connects two points, just like a line segment would, except that it's going to have to follow along the curve. So an angle whose vertex is at the center of that circle is called a central angle of that circle. So if I had my center here, and then I drew in 2 radii, this angle here would be called a central angle. And the sides of the central angle are always 2 radii of the circle. So this is a central angle right there. And then obviously these 2 that I'm now going to draw in green are radiuses or radii. So an arc that lies between 2 sides of a central angle is called a minor arc. It's a minor arc. And then using common sense, an arc that lies outside of a central angle is called a major arc. So what that's saying is I have a circle. Here's my central angle. I'm just going to call it CA for central angle. This right here would be my minor arc. And then this one all out here would be my major arc. This is the major arc. An arc that measures 180 degrees is going to be called a semicircle. What that is, if I had a circle and I had an arc that went from, it was basically half the circle, that's called a semicircle. So this here would be the diameter. And the central angle of a semicircle is what kind of angle? It is a straight angle. It is a straight angle. Okay, when you want to label something minor arc AB, the way we would label it is it would be AB with a little arc sign above it. And AB is a minor arc joining which 2 points in a circle. So that would be if I had a circle, here's A, here's B. I'm looking for minor arc AB. That means it's a segment that's joining A and B together. That's how we define it. So when you're naming arcs, if you want to distinguish between a major arc and a minor arc, the difference is that the major arc will have 3 letters. And the reason it's going to have 3 letters is looking at this picture here. If I wanted to label the major arc, I would have to add in another point. I'm going to call that C. So my major arc here would be point A, C, B, because it's the arc that's made connecting A to B, but going through C. So it would go this direction. If we just have AB, that means I'm going the shortest distance to get from A to B. So it wants to know what's the notation for the major arc AXB. So that would be AXB with an angle of the arc thing above it. So if AB is the minor arc and it has a measure of 120, what's the measure of AXB, the major arc? Well, you need to know that a circle has 360 degrees total. It's important to note that whatever the central angle is, this is 120, this minor arc here is also 120. These will always be the same. Okay? And then if I wanted to find this other one, AXB, that's the outside piece, well, I know a circle has 360 degrees. I know part of it is 120, so I'll do 360 minus 120 is going to give me 240. So my major arc would be 240. So the measure of the minor arc is 155. What's the measure of its central angle? So I know this is 155. Well, if that arc is 155, I know this piece is also 155. So my central angle is 155 degrees. So we know that 2 arcs are congruent if they have the same angle measure the same measure, and they belong to the same circle or to congruent circles. So I have in circle A, B, and C, D are intercepted by congruent central angles. So I have a circle. And I have points A and B. And I have points C and D. What they tell me is that AB is an arc, CD is an arc. And we know that AB measures 99. It wants to know, and CD measures 10x plus 9. It wants us to solve for x. So it tells us that these two are congruent. So if they're congruent, that means that they're equal. That means that 10x plus 9 equals 99. And I need to solve for x. So to get x by itself, I'm going to subtract 9 from both sides. So I get 10x equals 90. The last thing I'm going to do is I need to divide both sides by 10. And 90 divided by 10 is 9. So two arcs of a circle are congruent if and only if their associated chords are congruent. And two chords are congruent if and only if the associated central angles are congruent. So what that means, if I have two circles, as long as their chords are the same, like, so you have a couple different chords, but they're the same length, then they're going to give you congruent central angles. So if arc AB is congruent to arc BC, so AB is the same as BC, what is the measure of BOC? So BOC right here. Well, if these two angles are equal, then that means that those two arcs are equal, then their central angles are equal. So BOC must be 45. All right, number 1, what is the measure of AB? AB in this case is the distance straight from A to B. So we know this piece out here is 245. So to find AB, we're going to do 360 minus 254, which is going to give us 106. So AB measures 106. Number 3 says, what is a measure of XY? So XY would be this part. Well, I know the inside piece is 328, so I'm going to do 360 minus 328, which is going to give me 32. So this part is 32 degrees. Number 5 wants to know the measure of ABC. Now notice that means it's the arc made from connecting A to B to C. So it told us this half was 177, so we're going to have to do 360 minus 177, which is going to be 183. So that would be our answer for this one. Number 7 says AB and CD are congruent. So AB is congruent to CD. So it wants to know the measure of AOB. That's the angle made connecting A to O to B. Well, if they're congruent and this piece is 25, then this piece must also be 25. If AB and CD are congruent, what is the measure of chord AB? Well, if these are congruent from here to here, is congruent from here to here, then these chords must be the same. So if CD was 4, then AB must be 4.